Today we're going to talk about reversible reactions, chemical equilibrium, and you're going to do an activity called paperclip equilibrium. So we know that reactions, that we've talked about chemical reactions back in chapter 8, and we know reactants form products. And we also can talk about a reversible reaction. A reversible reaction is when products reform reactants. So a reversible reaction, the products can react to reform the reactants. And when you have a reversible arrow, it is represented with a double arrow. And you can also sometimes see them written like this. You can see it written like this, but there's a double arrow to show that in the forward direction, reactants form products, and then the reverse direction, products form reactants. And you're going to model this today by putting paper clips together and taking paper clips apart. When a system is at chemical equilibrium, the rate, not the concentration, not the amount, the rate of the forward reaction, that is reactants forming products, equals the rate of the reverse reaction, products forming reactants. And at that point, the concentration of the reactants and products remains unchanged. It does not mean that you will have the same amount of reactants and products. It just means that you won't change the amount of your reactants and you won't change the amount of product. And so we can look at a graph of a system moving towards equilibrium. You can see that we have the reactants A plus B forming the product C plus D. And so initially, you only have reactants and no products. And so as the forward reaction takes place, you can see that as the forward reaction takes place, the amount of the reactants decreases until it levels off. And as the reverse reaction, once reactants form products, then you will have, over time, the reaction rate increase and then it levels off. You're at equilibrium when the rate of the forward reaction equals the rate of the reverse reaction. That's the definition that I've circled in red of equilibrium. So again, the key word here is rate. At equilibrium, you could have different scenarios. I'm going to let you copy this table down. And so at equilibrium, you could have reactants favored. Say we have more reactants, less products. At equilibrium, you could have neither reactants or products favored. It means you don't have, draw these. So neither, in this scenario, neither are favored. Or you could have an equilibrium where the products are favored. And so what you're going to do is you're going to model this with a paperclip activity. If could please pause the video and hand out the paperclip equilibrium lab. After that's handed out, turn the video back on. Okay, so we have our reaction here is going to be taking two paper clips and putting them together to make two individual paper clips together to make two paper clips joined together. So the forward reaction is two paper clips joining them together. The reverse is taking them apart. And I'm going to model this in just a minute. The reason we're going to use paper clips is we can stop the reaction every 60 seconds to monitor the amount or the concentration of the reactants and products. This is not something you can do with a real chemical reaction. So this allows us to kind of see our reaction. Once you get into groups, and you'll be told how to get into groups, the first job is to divide up into roles. If you end up without having a group of 4, then somebody will have to take the time and record keep at the same time as doing the jobs. But 2 of you will be putting paper clips together, and 1 will be taking paper clips apart. And when somebody needs to be the timer and recorder, you have all the directions here. Make sure you read through them before you get started. The data table is made for you. You may not need all of those times, but they're there if you end up needing that much. And then you have directions to make a graph, and there's graph paper, and then you have your questions to answer. So what I want to do is model what you're going to do when you go back into the lab. Let me turn on my document camera. So you'll find at your station a container of reactants, and then you should find a container of products. The first thing you want to do is make sure that you only have reactants. These should all be individual, and you need to count and make sure you have at least 60 of your reactants, which are your paper clips. You shouldn't have any products. If the last hour left you with products, you need to take them apart. And so 2 of you in the group, your job will be to take the paper clips and put them together and make a product. And so 2 people will be doing this while at the same time, while one person is taking them apart to reform the reactants. And every 60 seconds you stop and you count how many reactants you have and how many products you have. You can use your cell phone as a timer if you'd like, and then you'll complete the rest of the lab packet. Make sure you read through the directions. When you're done at the end, make sure you have all your reactants and you've taken apart all the products. The lab will be due tomorrow in class. And just make sure you read through all of the directions before you get started, fill in everything, and then everybody's making a graph, everybody's doing the questions and the table.